Hello everyone, in this video we're going to focus on the learning goal. I can find the missing side of a right triangle using the Pythagorean theorem. So we've drawn some right triangles here and we filled in some of the sides, and the goal is to be able to find the missing side of one of these. So let's just quickly recall that the Pythagorean theorem says that if you have a right triangle like this, where A and B are its two short sides, also called legs, then a squared plus b squared equals c squared, where c is called the hypotenuse. C is the longest side of our triangle. So let's jump right in. Problem number 1 gives us two of the legs, 3 and 4, and we have to figure out what the hypotenuse is. We have to figure out what c is. So we just jump right in. We take a squared, so we can see that a is 3. We can see that b is 4. So now what we'll do is we will just take a and square it. That's 3 squared. And we add b squared. B here is 4. So we have 4 squared. And we know that those add together to give us c squared. Now we'll do a little bit of simplification here. 3 squared is 3 times 3, that's 9. 4 squared is 4 times 4, that's 16. And c squared is still just c squared. 9 plus 16 is 25 equals c squared. And now we've just got one more step. We've got to take the square root of both sides of our equation. If you're not sure, if these steps are a little bit confusing, I recommend going back to the learning goal before this, which is comparing roots to exponents. But yeah, so whenever we see something squared, we take the square root of both sides, which just gives us c equals, the square root of 25 is 5. So c equals 5. Notice that we only took the positive 5 answer because we're dealing with a triangle, we're dealing with lengths. Lengths can only be positive. So we forget about c equals negative 5 and just write c equals 5. For the next problem, they have given us two of the sides of the triangle. They've given us the hypotenuse is 13, so that's c. They've given us b, which is 5, and we have to figure out what a is. So just like before, we jump straight to the Pythagorean theorem. We take a squared plus b squared and then set it equal to c squared. So a squared is just a squared in this problem because we don't know what a is. B squared is 5 squared. C squared is 13 squared. Okay, now we do a little bit of simplification just like before. A squared can't be simplified anymore. 5 squared is 5 times 5, that's 25. And 13 squared, I don't expect you to know that, but 13 squared is 169. So we've got that a squared plus 25 is 169. So now notice what's different here is that we've got to isolate our variable. We have to isolate a, or isolate a squared. So that means we need to subtract 25 from both sides of our equation. So let's see what we get when we do that. These cancel, and we get a squared equals 169 minus 25. Well, that would be 144. So whatever a is, a squared is 144. So we just take the square root of both sides just like we did over there. And again, we only are concerned with the positive value. So a is the square root of 144, which is 12, because 12 times 12 is 144. So that's it for this video.